In lesson 9-4, we'll be talking about slope. So, access ramps. The access ramp from the sidewalk to the door of a hotel rises 8 inches for every horizontal change of 96 inches. So what is the slope of the access ramp? Okay, we've talked about this quite a bit before. So slope is always the change in y over the change in x. And y is always your up and down, or your vertical, and your x is always across, or your horizontal. So when they say that it rises 8 inches, that would be your y. So we're going to say 8 inches here, and horizontal is 96 inches. So that would be here. Okay, as slope, we would like to write this ratio in simplest form. So just looking at it, I see I can divide by 2, so I could get to 4, and I could get to 48. Again, here now I can see that I can divide that by 4 again, so I can break it down even more, and I'll end up with 1/12. So what this means is for every 1 inch of rise, you're going to have 12 inches of run. So thinking about that, you know, out in the real world, what that means is for every foot, you know, the ramp is going to travel a foot before it travels an inch high. So like this here would be equal to 1 foot, or 12 inches, and the rise is only going to be 1 inch. So it's only going to go up 1 inch every foot. So that's a pretty slow slope, which, you know, you think about that, you would need that for a wheelchair or something like that. So 1/12 is the slope, 1 to 12. Alright, so now finding the slope of the line using a graph. I know we're pretty familiar with this. So again here, the rise is 1, 2, 3, -3, and the run is +2. So the slope would be -3/2. And since we're talking about slope, just leave it as an improper fraction here. It makes more sense for us. Alright, now finding the slope using a table or given points. The points given in the table lie on a line. Find the slope of the line, then graph the line. So you could either find the slope using the points, or we could first graph it and then find the points. So we've done this before. Remember, using y2 minus y1 over x2 minus x1. That's the slope formula given points. Or, again, we could just take these points and graph them. So if we were to go ahead and do that, let's just go ahead and plug them in. We get -3, -2, which is going to bring us right here. -1, 1, and then we have 1, 4. Okay, we can go ahead and draw that line. Alright, from here we can figure out what the slope is. We're going up 1, 2, 3, so it's a +3. And we're going to run 1, 2. So we're looking at a slope of 3 to 2, where you're doing your run on top. Okay, if we did it using the slope formula, we could just plug those numbers in. We could do, if I say that this is my point 2 and this is my point 1, I could say 1 minus -2 over -1 minus -3, which this is going to be an so we get 3, and this is an so I get 2. So either way, I get the same answer using either the slope formula or graphing it. But in this case, it does say then graph the line. So if you're graphing it anyways, you might as well just graph it and find your slope that way. Alright, so here again we're reintroducing or revisiting the actual slope formula, that y2 minus y1 and x2 minus x1. It's just important that whatever point that you choose to be 1 or 2, you just keep it consistent. Again, if we remember and review here, I always chose the point on the right as my 2 value, which is the same here in this example. So the point on the right is the 2 value. And that'll ensure that your bottom, your denominator, is always going to be positive. Now your y could be either positive or negative depending on whether the graph is going down or up. So that's kind of always lets you know whether it's an increasing or decreasing graph. So it says find the slope of the line that passes through A and B. So looking at this, 3 would be further to the right than 2. So I'm going to say that this is my point 2 and this is my point 1. Keep in mind, it does not matter which one you decide for point 1 and 2. It'll work out the same way. But let's just go ahead and work this out as this is point 2. So y2 minus y1 over x2 minus x1. Okay, well this is point 2, this is my y, so I'm going to do 3 minus, now this is my y over here, I'm going to do 0. And then x2 is 3, and x1 is 2. Now when I work that out, I get 3 over 1, which is just plain 3. So my slope is going to be 3. If I were to actually graph this, it would be 3, 1, 2, 3, and 2, 0. And you'll notice I am going up 1, 2, 3, and running 1, so it's plus 3, plus 1. And of course you could go ahead and graph this line, and you're going to see that there is a slope of 3. Okay, so again, you could work this out by just graphing, or you could use the slope formula to figure out your slope that way. Okay, either way is acceptable. I would prefer you to really getting used to the slope formula and being able to use that. Okay, so finding the slope of the line that passes through x and y. Again, if we look at the x values, 3 it would be further to the right, so I'm going to identify that as my point 2, and x would be my point 1. So I'm going to do y2 minus y1 all over x2 minus x1. So plugging numbers in, again, here is my point 2. Y would be 0, so I'm going to say y minus, now I go to y1. So this is point 1 and this is my y, so I would put in 3. x2 would be 3 minus x1 would be negative 2. Alright, so I'm going to end up with negative 3, and this is an uh-oh, so let's fix that. We have a 5. So my slope is negative 3/5. So what that means is we're going to have a decreasing graph, and it's going to go down 3, and it's going to run 5. So that's what it would look like here on the graph. It's going to go down 3 and run 5, and it is a negative slope. Okay, and that's our last example for today. So if you want to get more help here, you can check the step-by-step homework helper for all your odd answers, or you could watch the online tutorials, or actually you could look back in your notes for other examples when we worked on the slope formula in the past.